So I wanted to cover everything you need to know about porting out the wastegate hole. So the problem with this is, or the reason why people do this, is because you'll have this boost creep. So the turbo will boost more than you want it to regardless of what you do as far as adjustments on the boost controller. The reason why is because the air cannot flow past this valve efficiently enough, so the pressure is still building up in the turbine housing and forcing this turbine to spin, which is forcing the compressor wheel to compress more boost into the engine than what you're trying to compress in. So the fix for this is to port this area out to match the flapper, but where people mess up is like they ported too much here. So when you try and close this, sometimes it can hang and stick open just like that. And if that's the case, then it won't boost. It will boost very little, if any at all, would be extremely laggy. So just keep that in mind. This is actually a forced performance turbo. So what we're going to do to fix this is to close this up, hold a press down to compress that, and then weld this arm so that it stays shut. But if you don't want to go external wastegate, in that case you go external off the up pipes. If you don't want to go external wastegate, you can properly port this to help with creep, but sometimes it may be really hard to completely get rid of it. But so the idea is, you port it out, but when you port this, to do it correctly, you're going to do it like a D shape. So you're going to leave an area here where this will still seal and not hang up. But I wouldn't port it this big. I think they went a little bit excessive with that. Usually I try and get it ported to about 28-30 millimeter or so, depending on the flapper size, because sometimes the flapper size is 28 millimeter. So if that's the case, just port it mildly, and then you just have to deal with the creep as it is. Or another way to help get rid of it is sometimes the situation is not, or the problem is not this. Sometimes people port this out plenty big, but they still have the problem. Usually it's the O2 housing that connects to this. Like if there's a divider between these two, I don't know if there is one on the Subaru or not, but on the DSM there's a divider that comes through here, and it routes this air pressure from the wastegate separately. So the problem with that is the area where the wastegate airflow is going through has a really thin place in it to where the air pressure cannot dispose of enough of it fast enough so that it's getting all backed up in here, which leaves the pressure to be stuck in here, compressing this turbine still. Another way to fix boost creep is to not start with a full 3-inch exhaust right here off this flange. You can just do like a 2.5 or something smaller, so it leaves a little bit of back pressure behind here. Now that will actually kind of hurt spool up a little bit, or potentially, but the idea is that you don't want to be boosting so high at higher RPM, because the issue is that then you could really blow up your engine if you're boosting more than what your car is tuned to do. Another problem is if you port this out so much, or too much, then it can make it hard to make boost. The reason why is because this exhaust pressure now has more surface area to force this open. So the exhaust pressure will actually outpower the wastegate pressure spring that is to retain it. So there are cases that have happened where this can actually be forced open before the pressure on the spring side can be forced to push it open. So you'll see this open from the exhaust pressure. So usually to prevent that, what you want to do is go with the wastegate spring that is about half of the target PSI. So if you want to do 30 PSI, then you want a wastegate spring that is at least 15 PSI, because it will help keep this closed. If you still have problems with it opening, then you definitely need to increase the PSI on the wastegate spring, or just buy a whole wastegate that has a tighter spring in it. So the whole definition of boost creep, if you haven't experienced this yet, is when your motor is climbing in RPM, the boost level starts to go up really quickly. So let's say you're at 3,500 RPM, you're at 20 PSI, which is the target. Then 4,500 RPM, you're still at 20 PSI. Then you get above 50 or 5,500 RPM, and the boost is just skyrocketing all the way to 30 PSI. That's what boost creep is. Now boost spike is when you're out there and you mash on the gas and it spikes to 16 PSI, and let's say your target is 8 PSI. The reason why it spikes is because the wastegate has not opened quick enough. Sometimes in that case it's because you have a boost controller in there, and the boost controller spring, it takes time for the boost controller spring to open and then the wastegate spring. The purpose of the wastegate is to control the boost level. So if the boost pressure is too high, or when it reaches the target boost, the wastegate arm opens to control that boost, to keep that boost pressure where it is. Now if it's stuck shut, or if you don't have a wastegate or a vacuum line on the wastegate actuator, usually it will do just all the boost it can until the pressure pushes this valve open from the exhaust side. If you have any questions about internal wastegates, you can ask them in the comment section below. Here's a shot of the front of this turbo. This has a GT35R compressor wheel.